Okay, standard 5, fifth and final standard in algebra 2. Everybody takes this standard on the final. So it's polynomial equations. Anytime I have an x power opponent higher than a 2, it's classified as a polynomial equation. Now with polynomial equations, the only way to graph them really is to make an input-output table and just pick a domain of 3 through negative 3. That's not what the domain's limited to. That'll just give me a nice range of numbers. Now, before we calculate these, there's a little thing I think will help with the arrows, because I'm picky about the arrows. Okay, so the very first term, the one with the highest power, that's negative, so this way will go down. Okay. Now, the highest power is even, so they have to go in the same direction. Okay. So again, you can tell right away what your arrows will do. Okay, now we just insert them. So negative 4, parentheses 3 to the fourth power, you just hit that with 4, plus 3, parentheses 3 to the third power, power 3, minus 5, parentheses 3, second power, plus 3, parentheses 3, minus 2. Okay, so I got negative 281. I'm probably not going to end up graphing that, but that's fine. Okay. I hit the up arrow on your compasses and just quickly go make all the 3's into 2's. All of them. Don't forget one. Okay, you got negative 56, so that's a little bit better. Okay, then I go up. I go 1, 1, 1, 1. Okay, and then out. So negative 5. Now when you do the 0, you can pretty much cover up all your x's, and you see there's a negative 2 at the end. So that's that. Okay, now it's clear we have to re-enter it and then put negatives in. Negative 1 to the power of 4 plus 3, and then negative 1 to the power of 3 minus 5, and then negative 1 to the power of 2 plus 3, and then negative 1. And then minus 2, that gives me negative 17, okay? Now I don't have to reset it, just hit up, and everywhere you have a 1, keep the negative, then you just put a 2. Okay, I got negative 116. Now 3. Negative 461. Okay, now, I'm not going to graph this, this, or this. Those are all in the hundreds. I'm just going to graph these points here. So I'm going to go right 2, then down 10, 20, 30, 40, 50, and then 56 would be right there. 1, negative 5, I go right 1, and then down 5 would be here since I'm going by ones. Okay, 0, negative 2, I just go down a ways, and then negative 1, negative 17. So I go left 1, then down 10, and right there. So just connect them. Some are like, oh, it's a parabola. No, it's not. Okay, it's not symmetrical. It's going to look like a parabola. So we know this goes down, and this goes the same way. Okay, boom. So having those arrows there before I find all the values does help me. Okay, remember, this goes down because we have a negative. This goes in the same direction because it's an even exponent. Okay, simplifying exponential expressions. Now, if you just look through them, I have no adding or subtracting operators, so it's the 3 boxes. So my bases are simply 3 and x. 3 is to the 1 power, but I got to take 1 times 3 to get it out of parentheses, and 2 times 3 is 6. We don't move these because they're positives. And then 3 to the third is 27. Don't you put 9 times x to the 6. 3 times 3 times 3 is not 9, or 3 power 3, it's 27. Okay, and that's been simplified. Okay, my next problem, no adding or subtracting operators within the expressions, so that's good. So I'm going to have 10 and 15 then times x, and times y. So 10 and 15 are both to the 1 powers. Now on x, we're going to have negative 4, and then the other x is on bottom, so I minus 2. Negative 4 minus 2 is negative 6. And then y, we have a negative 2, and my other y is on bottom, so I use subtraction 3. If I have negative 2 and take away 3, that's at negative 5. Okay, now the 10 to the 1 and the 15 to the 1 stay put, but both the x and the y move into the denominator so that their powers can become positive. Okay, and that's just going to give you 10 over 15 times x 6 times y fifth. Okay, you can reduce 10 over 15 to 2/3 if you want. I'm not going to require reducing though. Okay. I don't really want you dividing because that's a decimal. I don't want any decimals at the end here. Okay, no adding or subtraction operators. That means I will be making 3 boxes. So my bases are 5 and 4. And then my variables are A and B. So 5 would be to the 1, but it has to be multiplied by 3. That's to the 3rd. 4 is to the 1. It does not get multiplied. That's a 1. And then A, I have 2 A's. I have 2 times 3. That's 6. And then I need to add 4 because everything's on top because the line's right here. So that A is also on top. So 6 plus 4 is 10. Okay, now my B, negative 2 times 3 is negative 6. And these 3 factors stay in the same place. But not that factor. That factor is moving into the denominator, so we can make it 6. Okay, so 5 to the power of 3 is 125, and then 4 to the power of 1 stays it at 4, and then times a to the 10th, b to the 6th. Now I do want you to multiply these, because we know that's not a decimal. 125 times 4 is 500. So it's simplified. 500 times a to the 10th over b to the 6th. Okay, my next problem, no adding or subtracting operators, so we are going with the boxes. It's a little bit tighter fit though. Okay, here's my first box. I have a factor of 6, and then x and y, and then in the denominator is just more x's and y's. So 6 is to the 1 power, so 1 power. And then x, we have 3 of them. We have 1 plus 4 minus 2. 2 plus 4 minus 2. 2 plus 4 minus 2 is 4. Now for y, we have 3 of those as well. We have negative 3 minus 2 minus 3. Okay, negative 3 minus 2 is negative 5. Minus 3 takes you to negative 8. So the 6 and the x maintain their same position, but the y goes into the denominator where it becomes 8, and then 6 to the 1st is just 6. So 6 times x to the 4th, y to the 8th. Now, this next one, we do have an addition operator within the exponent expression. So that's a game changer. That means I do not use the boxes. I would be best going with a step 1, step 2, because we're going to have to FOIL. So get rid of the second power and just multiply by an identical parentheses. And then first, 5x times 5x, outer, 5x times 2, inner, 2 times 5x, and last, 2 times 2. Okay, now I find these 4 products. I get 25, that's x to the 2nd, 10x, 10x, and 4. Then I just collect like terms. I've got x to the 2nd as the lead, plus blank x plus blank. So we got 25, 10 plus 10 is 20, and then 4. So having that plus or minus operator is a game changer. Okay, that means you should be duplicating the parentheses, not just multiplying out. Okay, now the next 3 are the ones I really hate. Okay. Find the solutions of the equation by factoring unless I tell you not to. We have 5 solutions we need to find here for my x variable because we have x fifth, x third, and x. So that's 3 terms we have to factor. So greatest common factor. And then the t-table. Now, since we're finding more, we're definitely finding more than 2 answers. We have to find 5 of them, okay? We're going to need the more dops section, okay? You will definitely want to write that down. So more dops, question mark. Plus minus, plus minus. Okay. All right, so GCF, first things first. Okay. You do not have a negative in the lead. You have x third, x fifth, x third, x, so we want to pick out x. And then 2, 12, and 10, the GCF is 2. I'll just prove it to you. Don't lie, 2. Okay, so I put a 2x out here. Circle it. So 2x, 2x, 2x. Remember, the x's here cancel out. Now I want to put that 2x that came out right there because I'm going to need it for later. So that takes us down to 1x to the fourth minus 6x to the second plus 5. Okay? And now I do my table, A, B, C. So I will be taking A times C, 1 times 5, that's positive 5. So it's positive, so we're looking for a sum that would equal 6. 1 and 5, that would be it. Okay, so we have negative 6, so 5 is negative. Now, since we had a positive product with a sum, the signs have to match. They have to be the same. Okay, now A. Now, A is 1. That's good, but it has x to the fourth, which ain't so good. So we can get by with just 2 lines, but the x to the fourth has to go to x to the second, x second, minus 1, minus 5. Okay, now look at these 2 factors. That's a minus, and 1 is a perfect square. 1 times 1, x to the second, x times x. Okay, so I need to go up here, x, 1, 1. Circle those and then put them down here. Now we have to look at the second factor. Now you have a minus, but 5 is not a perfect square, so I go ahead and circle that, and I can't do that. So I have x to the second minus 5. Okay, now for your solution list, you set, you have 2x equals 0. Divide by 2, that's 0. X plus 1 minus 1 is just negative 1. X minus 1 equals 0. Add 1, it's just 1. X to the power of 2 minus 5 equals 0. You have to add 5, but you have to do the square root. It's a positive 5, so I don't want I in these 2 answers. Again, you can either find the square root of 5 on your calculator. You can write 2.24, negative 2.24, 23, whatever. Or you can just simplify it, which 5 doesn't divide by anything from there. So you just keep it square root of 5 and negative square root of 5. So again, pick the way you like better. Or you could also write 2.24, negative 2.24. Don't do it both ways. Just pick this way or this way. All right, next one. 4x to the power of 3 minus 64x. So we have 3 solutions. And we have x to the third and x. 0's there. So with x to different powers, we need to factor. Okay, there are 2 terms, so GCF. And then we see if we have adopts. I better. Now, since we're looking for more than 2 solutions, that opens up the possibility of perhaps some more adopts. You just got to be thinking about it. I like to map out my plan, okay? GCF negative, nope. X third and x, you do x. And then the GCF out of 4 and 64 is 4. Okay. Okay, so 4x comes out, circle it, and just bring it down here. Then we go divide by 4x. Okay, these cancel, and that gives me 1x to the second minus 16. Now that is adopts because 16 is 4 times 4. 1 is 1 times 1, and since x is to an even power, we just split that even power in half, x first, which is xx. So 1x, 1x, and then 4 and 4. Well, the plus you can circle, okay? If it's a plus, circle it, and you just put it alongside there. You can't factor that. Now you got minus, and I realize you got 2 times 2, but you don't have a power on the x. It's a first power, so you can't break a first power in half, okay? So get that out of there too, and it's 1x minus 4. Okay, so 4x could equal 0. So in my solution set I have 0 minus 4. I'm going to have negative 4. Don't need to divide by 1. 1x minus 4 is 0. And then my third is positive 4. Okay, this next one. 2x to the third power minus 7x to the second power minus 8x plus 28 equals 0. So we have 3 solutions because we have third power. So we got x to the third, x second, x, and then there's a constant. So that tells me we have 4 terms, so that's grouping. Okay, so grouping, parentheses plus parentheses. And the same thing with the lines outside, and then 1 parentheses with the line. Okay, so grouping, and since there's more than 2 solutions, we're going to have to check out the possibility of more dots. Okay, grouping, we're going to put 2x to the third minus 7x to the second, and then negative 8x plus 28. Okay, and away we go. Now we're going to not have a negative here, but we will here. We're going to have x here because we got third and second, so we want x second, but we're not going to put x here because 28 doesn't have one. Okay, now GCF, you're going to check out 2 and 7. That's 1. So you can put a 1 with the x squared if you want. I'm not going to. Then 8 with 28 is 4. Okay. So I factor out x to the power of 2 and negative 4. That gives me 2x, and these cross out, minus 7. And that's also 2x minus 7. So 2x minus 7 is factored out. Cross those out, and you end up with x second and negative 4. So x to the second minus 4. Okay, more dots. You have a minus, but 7's not a perfect square. So I'm just going to put that alongside it and get rid of 2 of those. Here you got minus 2 times 2, and you do have an even power on your x. So yeah, that would be xx 2, 2. So x plus 2, x minus 2. Okay, so you've rewritten it into factored form, and that is how we're going to solve it. So 2x minus 7 could equal 0. X plus 2 could equal 0. X minus 2 could equal 0. Add 7. 2 times x equals 7. Divide by 2. You can leave it 7 over 2, or you could write 3.5. You pick one or the other. Minus 2, you get negative 2. Plus 2, you get positive 2. Okay, and before I get to the story problems, I have this bugger here. X to the third minus 5x to the second minus 22x plus 56 is 0. So there's 3 answers, but it says it doesn't factor. So when I have 4 terms or more than 4 terms that don't factor, I need to use my synthetic division, the L. So we have 1, negative 5, negative 22, and positive 56. Now, we got to find an outside number. That's your first solution. So we got to trial and error. We're going to punch in 1. So 1 parentheses 1 to the third power minus 5 parentheses 1 to the second power minus 22 parentheses 1 plus 56. Okay, I did not get, that didn't work. So I hit up, and now I switch these 1s into 2s. And if this doesn't work, we're going to go 3. And if that doesn't work, we're going to do the negatives then, because I know I didn't put anywhere you'd go past that. Okay, so I have 2's now in, and I got my 0. Okay, so 2 is my first solution, so that's what I can divide by. So I drop my 1. The reason why that'll work, because you'll get 0 at the end. Then I take 1 times 2, that's 2. Then I add. Negative 5 plus 2 is negative 3. Negative 3 times 2 is negative 6. That's negative 28. Times 2 is negative 56. And I add, and I get 0. Okay, so what that accomplishes, it takes it from an x to the third to an x second. And this has x, that's a constant, equals 0. And now we can do our GCF-T from there. Okay, I have enough room, so I'm just going to do it from here. Okay, GCF, this is not a negative. You don't have x on everything. So 1, 3, and 28 is just 1. So enough with that. Okay, A times C, positive 1 multiplied by negative 28 is 28 negative, and difference of 3. 1 and 28, nope. 2 and 14, nope. 3 is a decimal. 4 and 7, yep. Okay. So 3 is negative, so I know 7 is negative, and it's a difference because of the negatives, so the signs would have to be opposite. Okay, so A is 1, but it is now 1x to the second, and that's good news. I can just make 2 parentheses, and I don't need to put an exponent on the x. Plus 4 minus 7, so that's F1, F2, and that gives me my other 2 solutions. So plus 4 could equal 0, x minus 7 could equal 0. Subtract 4, we get negative 4, and then add 7, we get 7. Okay, there we have it. Okay, this is an easy story problem. From 1990 to 2003, the number of inland lakes in Michigan infested with zebra mussels can be modeled by this function, the equation. N represents the number of zebra mussels, and T represents the years since 1990. Find the number of zebra mussels in the inland lakes of Michigan in the year 2000. All right, so there's my equation. N equals negative 0.028. Capital T to the 4th, so it doesn't look like a plus, plus 0.59 T cubed minus 2.5 T squared plus 8.3 T minus 2.5. Okay, so they give you the equation. Now, what do the variables represent? So N represents the number of zebra mussels. Zebra mussels. Okay, and it says T is the year since 1990. So did they give me any quantities for zebra mussels? I don't think that they did. Okay, so that N's going to stay in N. Now, they give you some years. Yeah, they gave me 1990 and 2000. I don't really look up here because that's just the information. So in this, they give me 1990 and 2000. Well, it's since 1990, so we need to take 2000. That's a T value, but we have to minus 1990. That's 10. Okay? I kind of like it when they don't give me letters to put there, or values. That means it's going to be easy. Okay, and then I just replace all my T variables with 10s. Negative 0.028 times 10 to the power of 4 plus 0.59 parentheses 10 to the third power minus 2.5 parentheses 10 to the second power plus 8.3 parentheses, 0.3 parentheses 10, then minus 2.5. Okay, I got 140.5, and that's your solution. Okay. Zebra mussels would be the label. Now, this is the one I'm more concerned that you can do. This takes a little bit more skill. A video game company's profit can be given by the equation P equals x to the power of 3 minus 12x to the power of 2 plus 35x. P represents the profit in millions of dollars, and X represents the number of video games produced in the thousands. The in millions and thousands mean if I get a value, I don't need to put the extra zeros. Okay. Currently, the company is producing 3,000 video games and making a profit of $24 million. What lesser number of video games will yield the same profits? So there's my equation. We always want to write that down. That should be the first thing I do. Okay, now determine what your variables represent, P and X. Now P's profit. Profit is dollars. Okay, you can just put a dollar sign. And X is whatever the product is, so that would be video games. Okay, they give you a dollar quantity. Yeah, $24 million, but we can just use 24. Okay, because it told me that was in millions. So P is going to be replaced with 24. Now, in the same equation, X is video games. Well, the quantity is 3,000 video games, and that is with the 24 million. So 3 will go in for X then. And we're going to replace these at the same time. Okay, so 24 equals parentheses 3 to the second. We're going to put 3 in. Minus 12 parentheses 3 to the second plus 35 parentheses 3. Okay, we're going to verify that that's that's actually 2. So parentheses 3 to the third power minus 12 parentheses 3 to the second power plus 35 parentheses 3. Yep, that must be true because I got 24. Now, here's the moment of truth. You can't get lost at this point. You keep the 24 the way it is, and you switch the 3's back so they're X's. Because you're trying to find all the values for X that will give you 24. So there's 3 of them. And we already have our first answer. We already know that 3 is one way to get to 24. Okay, so I need to subtract 24 from both sides, and I might as well use my synthetic division because I have my first answer. I don't want to try to use factor but the grouping and have it not work out. Okay, it's going to be really irritating. So then I have 1, negative 12, positive 35, negative 24. Remember, you got to get the negatives. You got to also make sure you move that 24. So I drop the 1. 1 times 3 is 3. Then I add. Negative 12 plus 3 is negative 9. Negative 9 times 3 is negative 27. Add, you get 8. 8 times 3 is 24. You get 0. Now the 1x to the third goes to an x to the second. X plus 8 is 0. So nice trinomial I have. So GCF and T. And actually, this is kind of weird. The T is actually going to work out here. Okay, I mean, you can go, say, fail and use a quadratic formula, but you're going to get the same answers if you do it right. GCF here is just 1. There's no negative. Okay, I take 1 times 8. 8's positive. Sum of 9. Well, 1 and 8, that's a sum of 9. Okay, so we have the 2 factors. Now, 9's negative, so that would make my 8 negative. And a sum and a positive means the signs have to match because a negative times a negative is the only way to get a positive. Well, a positive times a positive, 2. Okay, A is 1. It is x to the second, so I can just make one line of parentheses with x times x. Minus 1 minus 8. So it's F1, that's F2. So x minus 1 is 0. X minus 8 is 0. Plus 1, we get 1, plus 8, you get 8. Now, all those are legit answers, okay? Now, the X is the video games, and those were the ones by the thousands, so we put K, and K, just put games next to them. And actually, when we get down to brass tacks, it asks what lesser number of video games made yield the same profit. So really, 1's the answer, but they're all legit ways to make 24. So they would go down to producing 1,000.